Hello. In Unit 1, it was a big introduction section. We talked about a whole bunch of definitions, basically the overarching view of statistics and what was going on in statistics. And we talked about numerical data, categorical data. We talked about different kinds of sampling. We talked about controlled experiments versus observational studies. Whole bunch of stuff that we're going to get into in this class. Now in this unit, unit 2, we're going to zoom in on just one of those things. We said that, okay, we can roughly divide data into numerical data and categorical data. Well, unit 2 says, let's talk about numerical data. We're going to visualize it and talk about ways that we can describe it, descriptive statistics. Unit 3, we're going to visualize categorical data, okay? So that's kind of where we're at right now, and we're going to start by graphing, visualizing numerical data. We're going to do a lot of this throughout this unit in kind of different ways. Most of the stuff will eventually do with computers, but we're going to introduce it by hand so you can see a conceptual understanding of where it's coming from. Okay, you're not really going to need to do that much graphing by hand, but it's always good to start with it so that when you look in a picture, you have that experience to draw from. Okay, so kind of the things that we're going to be looking for down the line. We're not going to start with all of these right now, but down the line, we're going to be thinking about, okay, if we visualize data, what's the shape of this data? What's the center of the data? Where's this data kind of centered at? How spread out is it? Are there any unusual features and stuff like that? So these are some things to keep in mind as we go through this. And we're going to start with a set of 15 exam scores for a fictional statistics class. This is numerical data. It's discrete numerical data. Okay, all of these scores, there's no fractional points here. A bunch of integers. We're going to start by drawing a dot plot. A dot plot is really easy way to graph things when there's not a huge sample size, and has a great visualization. So to start with a dot plot, here's what you're going to do. You're going to graph a number line, okay? And you're going to have a smallest point on this number line and a biggest point on this number line. So to do that, just look at your data. What do you think the smallest could be? It could be 31, could be 20, could be 30. But it should be something smaller, like right. So I'm going to choose 30 over here. And then for my maximum, it makes sense to have 100, and we can just count by tens. Let's see how good I do. See how good you can do. Try to divide this into tens. We got like 30, 40, 50, 60, 70, 80, 90, 100. Just like I said. Just like I planned, everybody. Okay, so here we go. Once you have your number line, you just find where is each point on the number line and draw a little dot that's just sitting on it. If 30's here, 30 here, I'm going to use some colors. You just draw a little dot where 31 is. Just like so. And then we should probably fill these in, right? 40, 50, 60, 70, 80, 90. And then we just keep on doing it for all the other ones. We got one at 62. It's not a perfect exact science, everyone. Just do your best. 65 is going to be dead center here. 70 is going to be right here. 76 is going to be all over here. So take a moment. Don't worry too much about what I'm drawing right now, but pause the video if you need to and try to put these dots where you think they should be. And notice that there are two 82s. So then we start stacking the dots. Okay? Yeah, go ahead and pause the video to catch up and try to see if you can draw all of these dots where you think they should be. And we'll see if our answers look pretty similar. Oh my goodness, it's getting very crowded over here. We got a dot for 94 right here. Dot for 95 right here. 98. And then 100. The dot plots are just a simple visualization. Remember, eventually we're going to talk about shape, center, spread, unusual features. You can kind of start seeing that, right? Unusual feature is this 31 over here. That seems like a little out of the ordinary. Center seems to be around 80. The spread, well, kind of spread 20 on each side. Those are all topics that we're going to talk about more in this class. But that's all a dot plot is, okay? And now you know how to make one. This is probably the only one you're going to make by hand. But it's useful. Good practice. So now we're going to do another kind of visualization, and that's a histogram. Okay? So histogram, we all have seen histograms before. Just a quick note that the boxes for histograms touch each other. If the boxes don't touch, that's called a bar chart. We'll talk about that, I think, next unit, if I'm not forgetting. And then, so we're going to graph a histogram of this data with a bin width of 10. Okay. So bin width of 10 just means that there's, a width of 10 for every bar. So it's like every bar could be like a letter grade or something, right? 60 to 70 is going to be like a D, 70 to 80 is going to be like a C, and so on. And the very important thing is to label your graph and scale it correctly. Okay? So if you really want to get into the weeds and be a very precise histogram, usually we start at like decimals so that there's no ambiguity, right? If I say 70 to 80 and then 80 to 90, it's a little ambiguous. But what we can do is, I'm not going to worry too much about that here. All right. Yes, I will. Yes, I will. We'll be precise. Okay. So instead of going from 30 to 40 and then 40 to 50, that's a little ambiguous. We're going to take it down just a little bit. What we're going to do is 29.5 to 39.5. And the reason here, let's separate this in a bin and count. So when I say it has a bin width, right, that just means the size of each interval. Okay. And then we're just going to count how many things in that bin. And the reason why we're using these decimals is what we're really interested in is each one of these groups, 60 to 70, 70 to 80, and so on. But it looks ambiguous. You don't know which side is which. But if I had a decimal, notice this still does all the 30s. Because we have all integers. There are no decimals in our data. So if we write it like this, it's very clear that this has all the 30s, and we can graphically and visually see a very precise thing. So we're just going to go, and you can look at the original data. That's best. Or you can just look at your dot plot. That'll work too. So there's 1 in this bin. And then the next bin from 39.5. And again, it doesn't matter that these are the same here, because there's no data point that has decimals in it. And that's the whole point of adding decimals in your bins like this. To 49.5. There's nothing in there. There's nothing in the 40s. 49.5 to 59.5. There's nothing in the 50s. 59.5 to 69.5. Okay. There are 2 numbers in the 60s. Right, you can see that. And then 69.5 to 79.5. How many 70s are there? There's 2. There's going to be 6 80s and then 3 90s. So 6 80s, that'll be 79.5 to 89.5. And 89.5 to 99.5. And then you do get something a little bit weird here, and there's no real dodging the weirdness. We also have something at 100. We do need another bin, 99.5 to 109.5. This could make sense if there was extra credit or something. If there weren't extra credit, it would look a little silly. But there's not always perfect ways of setting up these bins. And your way of setting it up might be a little different. It did say that the bin width has to be 10, but it didn't tell us where to start. And again, if this is all weird and you really don't like these decimals, don't worry too much about it. We're going to be mostly using computers to generate our own histograms. The important thing is that you know how to read a histogram. Okay. So we do need to sketch and label our graph appropriately. So we're going to do that now. So we're going to, technically, right, we should have labeled this here for our dot plot as well, right? This is the grades, exam grades. We're going to label it the same way over here. Let's leave some room. Exam grades. All right, and then again, this up here, this box right here will be one bin. So that this is going to be 99.5. This is going to be 89.5, and so on. Uh, 39.5. We're almost done. Okay. So we have all of the bins that need to be graphed. Just like so. Now what we do over here is this is where we record the frequency of that bin. All right, where this is 1, this is 2, 3, 4, 5, 6. It's very important to label these things so it's a little bit easier to see. So, how many things are between these two values? Well, that's why we already made it's called like a frequency table. That's something we talk about more officially next unit. Well, we've already figured these out. So now we just draw boxes. In this region down here, the frequency is 1. I'm going to get a fat marker. We have this. And then in the 40s, from the next one, it's 0. So we don't draw anything. You could draw this if you want, but I'm just not going to draw anything. From 59.5 to 69.5, there was 2. Now you should see what's going on. So we can visually see, okay, how many people are in each bin. And there's no ambiguity here. Whereas if we did 50 to 60 and 60 to 70, then you'd wonder, and you might not care, but you would wonder, okay, which box gets the 60? Okay. So go ahead, take a moment, fill the rest of these in on your own. Pause the video if you need to. 69 to 79, that's also going to be 2. 79 to 89 is a big 6. Is up here. 89 to 99 is 3. And then, oh, I guess we have 1 over here. I guess it would have been best if we wrote 109.5 right at the end. And that's what your histogram looks like. And some of you more artistic people, you might do some shading. You do not need to do any shading or anything. But if you want to, it does make it look nicer. I would guarantee that at least 2/3 of the class is more artistic than I am, but that's a histogram. And now we can compare, this is basically the end of this video, but look that we can compare the one visualization of the data, a dot plot, to another visualization of the data, a histogram. So dot plots are really more useful if there's more stacking going on, I think. But you also get to see a lot more fine detail in the data for the dot plot, whereas histogram really lumps things together. On the other hand, a histogram is much easier to see patterns. There's fewer things that we have to look at. It's simpler. And then, but yeah, there's just 2 different visualizations there. Let me know if you have any questions, and that's how we can visualize numerical data. If you want to visualize numerical data in some other ways, don't worry, we got more coming. Bye-bye.